In today's lesson, we want to find the sums of arithmetic and geometric series, which is part of State Standard 22. We want to find the sums of both arithmetic series and finite and infinite geometric series. So our objective for today is to find the sums of finite arithmetic and geometric series. So in this lesson 5, we're only dealing with the finite series. Next section, we'll find the infinite series. First of all, here's a formula. The sum of the first n terms of an arithmetic sequence can be defined as the sum of the first n terms is equal to the number of terms times the product times the sum of the first term plus the last term, all divided by 2. So again, the sum of the first n terms, number of terms, times the sum of the first plus the last term divided by 2. This formula is useful, obviously, then when you know the first term and the last term, and that's when we want to use that formula. So let's look at an example. Find the sum of the positive integers from 1 to 100. Well, we know the first term, we know the last term. So we're looking for the sum of how many numbers? Well, from 1 to 100, there are 100 numbers. So n is 100. First term is 1, last term is 100, and we're going to divide that by 2. 1 plus 100 is 101. 101 times 100 will give us 10,100, which divided by 2 is 5,050. So the sum of the first 100 positive integers from 1 to 100 is 5,050. There's another formula we can look at, and this formula is different but also important because this formula is useful when you don't know the last term. So let's look at this. The sum of the first n terms, and its arithmetic series here, is the number of terms divided by 2, all distributed, times 2, double the first term, plus the number of terms minus 1 times the common difference. So again, the sum of the first n terms is the number of terms divided by 2, multiplied by double the first term plus the number of terms minus 1 times the common difference. So again, that would work in a situation like this one, where we know the first term, and we're looking for the sum of the first 40 terms. Now again, please remember that I'm not going to be so naive on the test that I know that you could sit here and just keep adding 3 to this till you get 40 terms. And I'm not going to do that. I'm going to ask for the sum of the first 4,000 terms. And with the formula, it's not going to be any more difficult, especially since you're using calculators. Without the formula, you're going to have troubles because you won't have time to write out the 4,000 terms, perhaps. So let's look. The first term in this formula is 2. The common difference is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. So let's substitute what we know. We're also looking for n is 40. The sum of the first 40 terms is 40 divided by 2. All multiplied by double our first term 2, plus the number of terms 40 minus 1 times 3. Simplifying is 39 times 3. 39 times 3 is 117. 117 plus 4 is 121. And that 40 divided by 2 was 20. So whether this was 4,000 or 40, still going to be fairly simple to work with the formula. 20 times 121 is 2,420. That's the sum of the first 40 terms. Again, if I only did 40 terms like this example, you could write all 40 terms out and just add all 40 of them together. But I would like you to know the formula, so we're going to choose a few more terms than 40. Several more terms. Well, what if it's in sigma notation? So we have the formula 5k plus 2 going from term 1 to term 20. And we're going to use this formula. The sum of the first n terms is n distributed to the first term plus the last term, all divided by 2. Why do we do that? Well, it's simple because we can easily calculate the first term if we replace k with 1. We can easily calculate the last term if we replace k with 20. So that should be fairly straightforward. First term, though, if you wish to find out what it is, it's 5 times 1 plus 2. So 5 times 1 is 5, plus 2 is 7. That's my first term. My 20th term, t sub 20, is 5 times 20 plus 2. 5 times 20 is 100. 100 plus 2 is 102. Now, again, we're looking for 20 terms because it's term 1 to term 20. There are 20 numbers in all there. So when we substitute it into the formula, Sum of the first 20 terms of an arithmetic series is 20, because the number of terms, times the sum of the first term, 7, plus the last term, 102, all divided by 2. Very simple math. 7 plus 102 is 109. 109 times 20 is 2180, which divided by 2 tells us the sum of the first 20 terms is 1090. So series notation and sigma notation turns out to be fairly easy for arithmetic series. How about the formula for geometric series? Well, for geometric series, the sum of the first n terms of a geometric series where we know the common ratio r, and that common ratio is not 1, is defined by the formula the sum of the first n terms of a geometric series is equal to the first term times 1 minus the common ratio to the n power, number of terms power, all divided by 1 minus the common ratio. So for a very simple example, evaluate the sum of the first 10 terms of this series, 3 times negative 2 to the n minus 1 power. Let's write down our formula. Let's try to find the common ratio and the first term. First term we can find by substituting n with 1 and simplifying that. 1 minus 1 is 0. Anything to the 0 power is 1. 3 times 1 is 3. Next step, common ratio is negative 2. We know that if you watched an earlier lesson, section 1, that a geometric sequence or series, the common ratio is this base that we are raising to some power. So that's our common ratio, negative 2. So if we substitute in 3 is the first term, 1 minus the common ratio, negative 2, to the number of terms power, which is 10, all divided by 1 minus the common ratio, 1 minus negative 2. And when we take and simplify, negative 2 to an even power is positive number. Negative 2 to the 10th power is 1024. 1 minus negative 2 in the denominator is the same as 1 plus 2. In the numerator, that gives us negative 1023. And the 3's in the numerator and denominator will divide out to 1, because 1 plus 2 is 3. And that tells me the sum of the first 10 terms is negative 1023. And that'll be our look at finding the sum of finite arithmetic and geometric series.